Hello, Algebra, and welcome to the first video of Lesson 7.1, Adding and Subtracting Polynomials. So we are going into a big chapter covering polynomials. Poly means many, and we'll talk about what these nomials are, in this case polynomials are. Okay? So, first thing, why does a constant have a degree of 0? So when we talk about a constant, what we're talking about is a number. For example, 8 is a constant. It has a degree of 0. Now, we don't even know what degree is yet, right? So let's talk about that, right? So first of all, a monomial. So this is your first vocab word of the lesson. A monomial is a real number, a variable, or the product of a real number and one or more variables with whole number exponents. So a monomial means it has one term. Mono means one. Mono, a mono, one on one, right? One term. It can involve a real number, it can involve a variable, or it can involve both. And it can involve exponents that are whole numbers, right? So a bunch of different ways to combine real numbers, variables, whole number exponents to get a monomial. Now, the degree of that monomial is going to be the sum of the exponents of the variables. Okay? So, why a constant has a degree of 0 is because a constant has no variables. Right? And if it has no variables, there's no exponents to add, so its degree is going to be 0. Now, to further explain, let's show you why a constant has no variables. So let's go 8x to the 0, right? So this would have a degree of 0 because the sum of the exponents is 0. But there's a rule that anything raised to the 0 power is 1. This x to the 0 is just the number 1. So this 8x to the 0 is just 8 times 1. And 8 times 1 is, of course, 8. And there you go. You see it has no variables. And again, as I told you, this exponent has a degree equal to 0. So again, that's kind of like a whatever, who cares. But it introduces you into vocab, monomials and degrees. The next example is very much more important. All right, so example B here. Why is 5x to the third minus 4 called a cubic binomial? Why is 5x to the third minus 4 called a cubic binomial? So again, we talk about polynomials, right? A polynomial is a monomial, or the sum or difference. The sum or difference of two or more monomials called terms. This word terms is very important. I've used it all year long, right? So in this case, this polynomial up here at the top has two terms. One term, two terms, separated by a plus or minus sign. Now, you can name polynomials according to the number of terms it has and according to the degree, right? So this box here talks about the degree. Okay? So right here, you have a constant, which is a 0 degree. You have 4x, x to the first, which is a linear 1 degree. You have a quadratic, which is the second power. You have a cubic, because if you add 2 and 1, you get 3, right? Add those exponents. And you have a fourth degree, because if you add 2 and 2, you get 4. Highest sum of the highest sum of the exponents of a term. Okay. And then again, you can see that it says fourth degree, so on, fifth degree, sixth degree. Okay. So in this problem, the reason it's called cubic is because if you look at your 5x to the third minus 4, this first term has a degree equal to 3. Sum of the exponents is 0. And this constant term has a degree equal to 0, right? There are no variables. So you pick the highest one. The third degree is the highest. So if it's a third degree, we call that cubic. So this table is important in terms of naming polynomials based off their degree. Okay, we're going to talk about the binomial part in the next screen. So now again, why is it called a cubic binomial? So now we're focused on the binomial part. So here are how you name your polynomials according to terms, right? So number of terms. 1 term, monomial. 2 terms, binomial. Bi means 2. 3 terms, trinomial. Tri means 3. And then 4 and beyond is just called a regular polynomial. Again, this table is very important as well. You're going to have problems where it just says name the type of polynomial. That's it. It's vocab, right? So if we look here, 5x to the third minus 4, you have 2 terms. 1 term, 2 term. When you have 2 terms, you are called a binomial. So that is why this is called a cubic binomial. Okay. So next here, let's talk about standard form. What is the standard form for this polynomial? And you can see it has 1, 2, 3, 4, 5 terms. You can see that its degree is 4 because that's the highest exponent. So we have a 5-term 4th degree, right? So it's a 4th degree and it has 5 terms. So just a polynomial. So standard form for a polynomial is where you write the terms in descending order according to their degree. So typically it's descending order of the power of x. So because 6x to the 4th is the highest degree term, we're going to put that first, and it's positive. 6x to the 4th. And then the next one would be x to the 3rd. It is a minus x to the 3rd. And then the next one is the 3x squared. It's a minus 3x squared. And then the next one is the 7x. It's a positive 7x. And then the last one is the constant. It has no variables, so its degree is 0 minus 5. And there is your polynomial written in standard form. Okay. And last but not least in this video, example 3, how can we add or subtract monomials? So how can you use properties of operation to combine the like terms and write this expression in standard form? So we are going to combine our like terms and write it in standard form. So combine like terms and write in standard form. Now they have these algebra tiles here so that we can physically represent this model. So we have a 4x plus a 3x squared plus a 2x plus an x squared plus a 5, right? So fortunately, all of these are positives. So this 4x means 4 of these green rectangles. 1, 2, 3, 4. This 3x squared means 3 of these x squared blue squares. 1, 2, 3. This 2x is 2 of these green triangles. 1, 2. This x squared, there's a 1 here. That means 1 of these blue x squareds. And then this 5 is going to be 5 little squares, right? Little ones. So 1, 2, 3, 4, 5. So if you look here, we can visually combine like terms by just combining the different algebra tiles. So first, I would look at the boxes, the 3x squareds and the 1x squared. That's 1, 2, 3, 4, right? 1, 2, 3, 4 x squareds. Then I'll look at the x's next highest degree. 1, 2, 3, 4, 5, 6. 4 plus 2 is 6. That's positive 6x. And we don't change it and make it like an x squared because these are still 6 rectangles. And then we only have one constant term right here that has 1, 2, 3, 4, 5 little squares. So we just add 5. And that is how you can visually combine these like terms. Now again, up here you can use like the underline method up here. So 3x squared and 1x squared is 4x squared. Then 4x and 2x is 6x, and then the plus 5 by itself. You could also use like circle, square, triangle. So you could say, okay, let's circle the x squareds. Let's put triangles around the 2x's. Let's put a square around the constants. You could do that too. Whatever floats your boat, to simplify, combine the like terms of a polynomial. All right, so this is the end of the first video. We'll get into the addition and subtraction of polynomials in video number 2.